Thanks, Margot. She explained everything about me, so I coordinated a lot of water quality monitoring. We've been doing these types of presentations for a couple of years now, and I really like them and really get to do a deep dive into the data. As my territory of coordination expands, it's hard to highlight each tributary's individual strengths and weaknesses. So these presentations really allow me to do that. So, you always got to start from the very beginning about what is a watershed. So this is my favorite diagram of a watershed. You can see the dotted yellow line is the outline, and a watershed is an area of land on which water drains to a particular water body, river, lake, estuary. And then, of course, within watersheds, you can have sub-watersheds because you have tributaries. And an important thing that this diagram really captures is that what happens on the land affects the water in the watershed. So this farm, the city are affecting the water in the watershed. So when we're thinking about water quality, trying to think about what affects water, like I said, things that happen on the land. So when we think about land use, obviously anything that's happening on the land and then is getting wet and potentially getting picked up when it rains or when snow melts. And what land use is being done affects how that water behaves. So if we are looking at the left-hand picture, we have 4 land uses: forest, pasture, suburban, and city. And then there's a little graph that shows what happens when it rains. And in the forest, you get either evapotranspiration, which is the combination of plants taking up the water, which is called transpiration, or evaporation. They're kind of hard to tease out, so we tend to lump them together. And then the yellow and brown are different types of groundwater flow, shallow and deeper groundwater. On pasture, which is still mostly green, but there aren't as many trees and maybe some of that land is compacted, you're getting a little bit less of that evapotranspiration. The groundwater movement is maybe a little shallower, and you're starting to get this red line, which is surface runoff, which is just water that hits the ground and heads straight to the nearest body of water. Then we move to a more suburban setting. And we get once again, less evapotranspiration. You think there's still green space, there's lawn, there's a couple trees. We have a lot more pavement, we have a lot of roofs. So the groundwater is even shallower, and we're starting to see a big chunk of surface runoff. And then of course, if you move to a city, which is primarily pavement, very little green space, very little ability for water to get into the ground at all, you get no groundwater, maybe a few street trees and puddles taking up water and evaporating it. But most of that water is hitting the ground and going straight into the nearest body of water. And we can see that the diagram on the right shows the response to what happens when it rains, what the river flow level does in an original stream, which is maybe forested, versus an urbanized stream. So the original stream is red, the urbanized stream is blue. And what we see is for the same period of rain, you have a quicker increase, a higher peak, and a quicker decrease. Which would mean more flooding and more kind of flashy flooding is how we call it. Whereas in a forest, you'd kind of have some water gets there really quickly, some water gets there a little slower. And so you have a lower ramp and then a lower peak. So let's look at the Williams River watershed. Here it is, just set with the outline of the watershed on Google Map imagery I picked that because most of us look at Google Maps from time to time, and it has a few things outlined. So we have the main stem of the Williams River, and then I've also highlighted the middle branch of the Williams River because that is what we have monitored in the past 5 years. All right, so here's where we've monitored in the past 5 years. Like Margot said, we've been monitoring the Williams River for a lot longer, but it's really easy to feel like the past 5 years is maybe the most relevant data. So you can see our pink flags are our sites. They're labeled. In the past 5 years, we haven't really monitored below downstream of the Bartonsville Bridge. We used to have some sites lower down. We had one in Herrick's Cove, but that water is mostly still. And so maybe wasn't what we were looking for. And then we had another one under a bridge, I forget what it's called. But the access got too dangerous to sample consistently. So we're mostly focused in kind of this middle area. And on this blue chart, hopefully you can see the check marks are all parameters were monitored. So volunteers collect samples for E. coli bacteria, total nitrogen, and total phosphorus are the 3 I'm going to talk about, and I'll explain them later. But also over the years have collected conductivity, turbidity, and chlorides. And then if there's a star, which in 2020, the program that tests for nitrogen and phosphorus was canceled due to COVID. So we did just E. coli at sites of recreational interest. And then in 21, the program restarted, but much fewer sites were selected to participate. So we had this past summer 2 kind of bacteria sites and 2 sites that did all bacteria plus nitrogen and phosphorus. Let me check my notes. Oh, and then this base map is the Google satellite, so you can get kind of a feel for the land use. You can see the dark green is trees, and then maybe the lighter green is fields and stuff like that, where roads are. So one of the things that makes reviewing the data that my wonderful volunteers collect every year so difficult and comparing it year to year is that every year the river's doing something different. And so here's a chart of the stream flow over the past 5 years. And this is a linear scale. So all of the y-axis is kind of equidistant. And you can see that tends to cluster around the bottom. And then we have some really big peaks. That's when it rains. We also ask our volunteers to note on their field sheets, but we also are able to check this because there's a USGS gauge on the Williams River, whether it's low, moderate, or high flow. And those lines are marked here on this chart, where low flow is kind of the lowest 25% of all flows. High flows are the highest 25%. And then that middle 50% is moderate. And prior to 2019 and earlier, we mostly only monitored mid-June through August. And our goal was only to sample kind of dry, low flows. And then in 2021 and looking forward, we actually start monitoring for nitrogen and phosphorus at the beginning of May. And we are asked to actually specifically go out and collect sample during these high flow periods. And that just collects a different set of data. So we are seeing that transition in this presentation. And then here's also a look on the logarithmic scale, because on the linear scale, you can't really see what is happening in the low flows versus the high flows. So these kind of compress the high flows, and you can highlight the low flows. And we can see, basically the later half of the summer, more often than not, is low flow. But in the past few years, since I've started doing this, we're starting to see a lot more of really wet late summers, but dry early summers. And so we've got some of each in this presentation. So first things first is the E. coli bacteria. And so we monitor E. coli bacteria to determine the level of risk for recreation. So swimming, boating, fishing, tubing. It's split into two categories or two thresholds. The first is primary contact, which is usually shortened just to swimming. So anything where you're immersing your full body in the water and you are likely to get water in your mouth, in any scrapes or anything like that in your eyes. And the EPA and the state set that threshold at 235 organisms per 100 milliliters. There's also a secondary contact threshold that's usually shortened to boating, but anything where you're not directly in the water, but you're likely to get maybe sprayed with water. And that level is set at 625 organisms per 100 milliliters. And E. coli itself is not what's actually likely to make you sick if you're coming into contact with water. However, it does indicate that the water has been contaminated with human or animal waste, and its presence in higher numbers indicates the likelihood, or the greater likelihood, that there's something in the water that would make you sick, even if it's not E. coli itself. Sources of E. coli include agricultural and urban runoff, failing septic systems, leaking sewer, pet waste, wildlife. And we pretty consistently see increased levels after rainfall. And our volunteers recognize this bottle, we fill that up, and then the fun part is actually in the lab when you get to put it in these trays and then stick it under a black light to see if it lights up. And that's how we count the bacteria. So I'm going to present each parameter in two ways, each of which is imperfect, because this data is occurring in time and space and flow and some other dimensions as well. And we just, we can't fully capture each one on a two-dimensional chart. So the first is a pair of line graphs that are set up as profiles of the river. So, and then split into wet and dry, because often dry weather and wet weather bring back different results. And then across the bottom, we have the river miles. River miles tend to start at the mouth and move up as you get further away. So mile 0 would be at the Connecticut River. Our lowest site is at mile 7, moving up to 13. Most of the sites have a number attached to them if you're a volunteer, and your number is actually the river mile. This one also, because we monitored the middle branch, I put it across the bottom where the middle branch comes in. And then we have E. coli on the y-axis and our 235 threshold marked. So what you can see and perhaps expect from what I said previously is that the numbers tend to be a lot higher in wet weather. 2018 seemed to be particularly egregious. But other than that 1 year, the numbers on the main stem of the Williams River look pretty good. They tend to average out below that 235 number. When I first started, we were really concerned about the Rainbow Rock swimming area having high E. coli, but that seems to have calmed down in the past few years, which I don't know why, but I appreciate it. Rainbow Rock will be around right here. right below the confluence with the middle branch. In the past 5 years, we've had 3 sites total on the middle branch. The furthest up off at that Blue Hill Road crossing, we only monitored for 1 year. School Street Walking Bridge, we monitored for 3 years. And then above the confluence, which I'm sure has a better name that maybe you all could tell me, it's the swimming area right where the where the rivers come together, on over the railroad bridge, or go over
We
the
call it
railroad
train
tracks.
bridge.
Train bridge, great. You know, some of our Massachusetts beaches have really fun names like Bare Ass and Sunburn, so I didn't know a good one like that. But train bridge there. So and once again, 2018, you see a little bit higher on the wet weather, but overall the middle branch looks great. A great place to be swimming, I think. And then here are the same results, but broken down by flow level. This is a little bit less effective for E. coli because we see it so heavily influenced by whether or not it's rained recently. So what you'll see is that the low flows tend to be the lowest, although we did seem to capture at least one really high number during a low flow period and at the middle branch site, the train bridge. And but the moderate level could be either wet or dry. So we see both really low numbers and really high numbers. But you can see the average is these stars, and overall the averages still tend at any flow level, even high flows tend to be below the swimming standard. The next parameter is total nitrogen. Here we have a cartoon about the nitrogen cycle in our environment. So nitrogen is a nutrient that affects plant growth. It is the controlling nutrient in saltwater ecosystems. And we care about it a lot in the Connecticut River because in the Connecticut River watershed, which includes, of course, the Williams River, because eventually the Connecticut River ends up in Long Island Sound, which has too much nitrogen in it and is experiencing harmful algal blooms and hypoxia, which is a lack of oxygen that is not good for the ecosystem. And so the total means that it counts all forms of nitrogen, which includes nitrates, nitrites, ammonia, etc. The sources are, again, agricultural runoff, wastewater, failing septic systems. And this is a very mobile parameter. We'll see that it is less affected by rain. So here you can see that the nitrogen does tend to get diluted in the rain. So the wet weather graph is slightly lower than the dry weather graph in general. This suggested level line is actually an EPA suggestion based on the ecoregion, but all of these results meet the official Vermont standard, which is very lax. So I like to hold our rivers to a higher standard that achieves our goal of being protective of Long Island Sound. And you may notice that it starts pretty low. We're definitely mostly below that suggested line, and then we get really high as we move into mile 8, and then it stays high as we move down to mile 7, and at mile 8.6, that's our missing link road site that is in the middle of a bunch of farm fields. And we're seeing that effect pretty strongly, I would say, and consistently. All of these lines are the same shape. Looking at the middle branch sites, looks great. So we can rule out the middle branch as the source of nitrogen. These are really low numbers. Then if we look by the flow level, we can see very clearly that the total nitrogen gets diluted in higher flows. And that's the nitrogen just dissolves really well in the water. And so add more water, it just gets diluted. But we can see very clearly here that the level increases at the missing link road site and stays high as we move downstream, but is very low coming from the middle branch. For total phosphorus is another nutrient affecting plant growth. It's the controlling nutrient in freshwater ecosystems. So that's why it's the primary nutrient of concern with regards to Lake Champlain. So you hear a lot about that if you live in Vermont. And it, once again, the total means that it counts all forms of phosphorus. This includes organic and inorganic, dissolved and suspended. If it's phosphorus and it's in the sample, we count it. Once again, similar sources to nitrogen, agricultural runoff, wastewater, failing septic. An interesting thing about phosphorus in comparison to nitrogen is that it is very sticky. The volunteers know you collect your phosphorus sample in the glass tube, and that's because it would just stick to the plastic and they won't be able to get it out again. And also, you know that you only fill your glass tube once and you have to note on your field sheet if you fill it more than once. And that's because even with the glass, if you empty it and fill it up, some of that phosphorus will have stuck to the sides of the tube. So what it means is it also sticks to everything in the river and it tends to be transported with sediment. And so we once again see that levels are affected by rain and turbidity. So once again, we see big differences in wet and dry weather. The wet weather, it could be, a lot of it depends on how wet the weather was and how much sediment got picked up in the storm. What's interesting to me about, well, a couple things that you can see is this graph is almost perfect at showing the different ways that phosphorus is transported. So the lower site in mile 10 has like slightly higher phosphorus, but not too much during dry weather. And then you might notice that in the wet weather, that site tends to be higher. And that is where the wastewater treatment facility is. And the wastewater treatment facility is allowed to discharge phosphorus into the water. That's fine, but what tends to happen is it tends to accumulate in the sediment right downstream of the facility, and then in a big rainstorm, that sediment gets picked up, and that's when the phosphorus moves downstream. It's not a steady trickle in the same way that nitrogen is. And then once again, in dry weather, we see this missing link road site is the highest. It's right in those fields again, and it kind of, you would imagine that the phosphorus is falling out as the, and sinking back down to the bottom as water moves downstream. And in wet weather, we can see that those numbers stay high because that sediment is also moving. And once again, middle branch coming in solid, really low numbers. If we look at the flow levels, you can once again see that in moderate flows, this below the wastewater treatment facility is one of the higher sites. It's not included in the new early spring high flow targeted sampling, so we don't have as many high flow samples. There's only one in the past 5 years for phosphorus, so we can't actually compare the high flow to the two downstream sites. But once again, you can see at these further downstream sites that we're seeing excessive phosphorus kind of all the time. Just checking my notes. Okay. So those are the three I'm going to focus on. And volunteers started looking at chloride in 2021. So in the next few years, maybe I come back and do this again in a few years, we'll be able to talk about chloride, which would be road salt. But for now, here's my conclusions based on the past 5 years. Great bacteria levels, which was not the case when I first started. But now I feel confident saying the Williams River is a great place to be hanging out in on a hot summer day, as long as it hasn't rained immediately beforehand. And upstream, there's acceptable nutrient levels, and the middle branch doing really well. But agriculture has a huge impact on the nutrient levels, and there's some impact from the wastewater treatment facility. And then finally, I'm open to reconsider monitoring the lower river, especially for recreational sites, but I'm also open to suggestions of areas of concern, or maybe a site between the wastewater treatment plant and the missing link road site to kind of get a better handle on where the nutrients start being elevated. So in addition to answering any of your questions, these presentations are a great opportunity to hear about your concerns, you, the local people, what your concerns are about the Williams River, and then any other potential sources that maybe I should know about, consider monitoring above and below, and of course, happy to answer any other questions.
So I don't currently see any questions in the chat, but this is a great time. If you have a question, feel free to either raise your hand or jump in, and we can get that addressed. Oh, we do actually have one now that just popped into the chat. And John asks, I'm curious to know what can be done to mitigate ag runoff at the Missing Link Road area.
I mean, anything to slow down water runoff from going straight from the field into the river. It's been a while since I was exploring that area, so I don't know the state of any buffers, which is just like a strip of trees and shrubs to slow things down. So Susan is shaking her head no. Anything like that would really help. We just, the goal is to slow that water down and make it go into the ground before it gets into the river, and that helps slow things, lower the things. And I saw a question about the reduction in sites for 2021. It is not due to lack of volunteers. It's more due to lack of funding for the program, and a change in priorities.
Whenever we've discussed the farm, Roman Farm, which is up there by their cornfields extend to the river at Missing Link Road. I've always heard from, I think, Marie, that they follow all the accepted agricultural practices there, and that we kind of shouldn't be picking on them as a source. I think that was more when we were talking about bacteria in the past, years ago. But it does seem like it's pretty obvious that nitrogen and phosphorus are coming from that area. And I did that site one year when we had to shift around, and you walk through the cornfields to get in down to the river there, and it just runs. There's a sort of a gravelly beach at the edge, but that's it. And their fields extend all along the river from just below, a little bit below Rainbow Rock, all the way to that bridge. And they're on the other side of the road up off of Route 11 to where the river, I guess, where the middle branch comes in.
So as a follow-up to what Susan was just saying, and John asked if there are programs to help or encourage farmers to install buffers. And the answer is yes, there are. There are definitely buffer planting programs that will help farms or any landowner along a river that does not have an adequate buffer to help design and put in buffers. The conservation districts are a great source for consulting, and they have access to different funds to help put in buffers. The Connecticut River Conservancy also does buffer plantings. So Ryan and some of the colleagues that he works with are very good at helping landowners identify where the buffers should go, what should be in the buffers, and then help plant them. And there, as I said, there are funds. And what it really takes is a willing landowner to work with one of these groups. So, and that's where local people can be a great resource, because if you know the landowner, or of the landowner, and you're willing to approach them and just broach the idea, sometimes further inroads can be made by those local contacts than by just some group representative saying, hey, I noticed you don't have any buffers. Would you like to talk about it? That's easier to ignore than someone locally who's your neighbor saying, hey, there's some great programs out there that are available to help you examine if this was something that would be beneficial on your property and would even help pay for it. So that's where people who are local can really partner up and help the different partners get access and inroads to talking with landowners. And it's never approached as like a punitive thing, like, hey, you don't have adequate buffers and you really should. It's always buffers are not only protecting the river, but they're protecting the farmland too from further erosion or eating away into their land as high waters keep washing away at the banks. So there's benefits on both sides, and it's definitely can be a win-win all around. So Chester, where some of these agricultural farms are technically in the Ottaquiche Conservation District territory, although I'm not sure what their capacity is, and sometimes they work with neighboring conservation districts like the Windham County Conservation District, especially since it's right on the border, to talk about who's going to work with them. So you could probably reach out to either one. You could also reach out to Corey, and he could, not Corey, that's the Conservation District in Windham. You could reach out to Ryan, and he could put you in contact with his colleagues at the Connecticut River Conservancy who do river buffer plantings. And we'll make sure we put some of these contacts in the chat for you all.
Do we know if the Department of Agriculture does anything, like recommends planting buffers? I thought it was part of
it's a best management
accepted
practice.
Yeah, I mean, we try to maintain it from our field.
And there's different depending on the agency or the group that is installing a buffer. There are different buffer widths that are recommended for sites. Marie, you might be able to help me out here with some of the, I think they range from anywhere from 35 to 100 feet.
Yeah, any of the ag fields, certainly, you know, it's always a tough call. The accepted agriculture or the required ag practices, which they are now, require buffers along waterways, including ditches at this point. And certainly the large farm in Chester could use enhanced buffers. There's also some agricultural land in those fields that are actually hydric soils. So, you know, they're basically converted wetlands. And you have to balance those agricultural needs with the water quality needs. So certainly enhanced buffers all along the river would be great. And as Margot said, those programs are available. The Agency of Ag has programs for buffers. And you know, for agricultural fields, NRCS programs and the EQIP program and stuff are certainly the first go-to. But there's also Fish and Wildlife, U.S. Fish and Wildlife money called the Partners for Fish and Wildlife program, where they'll assist farmers with not only buffer plantings, but if it's an animal operation, they'll pay for fencing and pay for watering the animals so they don't have to access the river. There's a good number of programs out there, and as Margot said, and I'll stress, is none of this is mandatory. So it takes that willing farmer to make the commitment to have somebody come on their farm and look at it and help them out and present them with those programs. And there's a cost share for the farmer to participate in these programs. It's usually covered 75-25. So the farmer still has to come up with costs. And yet, again, I'll point back to CRC, who hosts another NRCS grant that can actually help the farmer pay that cost share. So, you know, usually we can work something out where the expense to the farmer isn't really that great. So hopefully, you know, if the farmer, and I'm not sure the last time someone reached out to the producer there, but those are all options, and it would be great to get out there and really see what could be done to help the water quality. And again, Margot covered it really well. It's protecting the land. You know, those buffers are holding that land in place. And when it does flood, which we know it does, we've seen it, those buffers keep all that debris from coming out onto the field that then has to get cleaned up. And it keeps the water moving slower because it's got all that stuff in the way. It keeps the ice out from getting up onto the fields when you've got a good buffer. So there's a lot of advantages to the farm to do that. So if there's a contact and there's a willing person, there's plenty of folks on the technical assistance end who are glad to go out and help.
And we're at CRC are just at the beginning phase of searching for projects in Vermont specifically to reduce nitrogen. So just, and like Marie said, I think that unless a landowner wants to chip in, most of the restoration work that we do is at no cost to the landowner. Very good at finding grants and matching projects with other projects so that they help each other and all that stuff.
So Ryan, Frank asked, he appreciated all the data. It's nice to see it. Who's the lead person to direct the farmer to?
If you know Ron, then he's the restoration guy, or Kathy. But you can also put them through me or through the conservation district, depending on what approach you want to go through.
Yeah,
But
I
like,
guess
since Frank is in good contact with you, he could just go to you and then.
Yes. I know sometimes people have relationships also with some of my coworkers. So.
No, and again, thank you for all of that. Yeah, and having that direct contact person, so it doesn't seem like you're chasing something all over the board. It would be really helpful to be able to have that clarity from the landowner.
Yeah.
And then to be able to continue to educate, people in the watershed, that it's not just, as you folks have very clearly, illustrated, it's not one person, it's a collective. And that if we can all contribute a little bit, it does make a huge difference. And just a quick shout out to thank you to Ryan and Margot and Marie and all the other volunteers that are part of this group gathering, because this is our data. So it's a nice science fair project, and I hope we all get an A. So thank you.
Yes.
No question about that.
So one of the things that we were hoping to hear from all of you is that, you all are the people who are the closest to the river. You know this river better than anybody because you live by it, or you recreate in it, you see it. What are some areas of concerns that you have, or what are some things that you've noted over the years that you're curious about or think that people should be aware of, that you're kind of like, hey, I wonder if that's an area of concern? We would love to hear those kinds of things, because again, we cover a lot of the region. We don't just cover the Williams River, and you all are the experts on it. So we would love to hear from you about things. John?
Well, yeah, am I muted? No, I'm not muted, right? Okay. Yeah, I just have a question. I lived just below that railroad bridge that's just below the Missing Link Road, and I've lived here for about 2 years. One of the things that I was curious about, and maybe this isn't, maybe this is outside of what you're talking about here, but in terms of the fisheries in the river, I have been told by people who've lived there all their lives that they used to fish on this property when they were kids, and there's this great fishing hole and everything, and there's nothing in there now. And what I was told was that it was after the hurricane came through 10 years ago or so that it kind of wiped out the fisheries in the Williams River. But I'm curious if there's anything being done to restore that.
You want me to take that one?
Yes. Our volunteers don't monitor the fish, the state.
You're right. No, I understand that.
So I'll go back even farther and say that a lot of, I'll call the old timers, always say that the fishing was way better 30 years ago because there was so much more stuff in the water. And that's very true. So, before wastewater treatment plants and all those kind of fun things, there was a lot more for them to eat. It wasn't good stuff, and I don't know if I would have wanted to eat the fish, but there were a lot more fish because there was a lot of food. Now the water is cleaner, so they're eating better food, and they're certainly more healthy. Following Irene, so I would respond that there's a couple of things going on. First of all, the habitat along good stretches of the Williams is really lacking. There's a lot of areas that don't have any buffers. So when that happens, the sun is just beating on the river and warming it up, and particularly trout. They can't take the warm water. So they leave in the summertime and they go up the tributaries where there's cooler water and more shade. So yes, there are fewer fish in the main stems in the summertime because it's just too warm. The other piece of that is that when there are no buffers and when things like Irene happen, there's no wood in the river. Right, you can drive along the Williams and there's no trees, downed trees, there's no leaves, there's no nothing. And it's just a flat bottom that has no habitat for fish, right? So we need those buffers to get big enough to start falling down, right? The trees need to be large enough that they eventually collapse into the water, and that's what creates the habitat. If you fish, you don't go to those straight stretches, you go to the snags and you cast to the snags because that's where the fish are hanging out. If we have no snags, we don't have any habitat. So the long term in building up those buffers so they will fall down eventually, that's kind of what we need to do. One of the positive outcomes of Irene is the negative is that it took all that stuff and it washed it down to Connecticut. The positive is that it eroded banks so badly that 10 years later, there's all kinds of trees falling in. And that's a good thing. So, when you look at it from a habitat perspective, I would say that, there are fish in the Williams. We do have fisheries biologists who monitor that, and they go out and they shock the fish and they count how many thousands per mile, all those things. They're there, but again, the water is too warm and there's a lack of habitat. So projects that could be done, we work a lot with fisheries biologists and local Trout Unlimited chapters to bring that habitat back. We don't do it so much on something the size of the Williams, because when those trees go in the next big flood, they don't necessarily stay there. So we work a lot more on the smaller tributaries to create that habitat. When there's no down trees, we actually down them to bring that wood back in.
Right.
So
I was going to ask if that was something that we could do, or
yeah, and there are things that
yeah.
can be done in larger rivers like the Williams.
Yeah, we actually have beavers that are active along our piece of the river, so they're
That's
also
cool.
doing their part. Yeah,
They like to down trees.
yeah.
So hopefully that answers your question.
Yeah, I think so.
So there was an exchange, just want to point out, because people are not watching the chat, a good exchange about Japanese knotweed and whether that would be an effective buffer since it's so prevalent along our river now. And the short answer is no, Japanese knotweed is a terrible buffer. And it's because it has such a shallow root system and it does not hold the soil. So anytime a big storm comes down and high water levels comes through the Japanese knotweed, it takes the soil and it takes the knotweed all downriver. So for example, after Irene, I suspect it happened along the Williams. I know it happened along the Saxtons River. After Irene, there was a lot of Japanese knotweed up in sort of the Grafton area. And after Irene, it went downriver, and we now have knotweed, just huge stands all along the river. I suspect the Williams is probably a similar state. And unfortunately, though, it does not provide the diversity of habitat for critters along the shorelines, nor does it really hold the soils. Japanese knotweed is one of those difficult invasives. And then I wanted to point out that there was a question about water temperature results. And I know we do a little bit of monitoring for that, Brian, but can you just talk about any trends that you've noticed about water temperatures?
Our volunteers do collect water temperature at the time of sampling. But because everyone's kind of sampling at a slightly different time, it's really, there's not like a good trend to show, because like, I have volunteers on the whetstone, for example, who sample at 5:45 in the morning, and then someone who's sampling at 9. It doesn't mean that the site that gets sampled at 5:45 is cooler. However, it does allow us to keep an eye on the temperature because we would like to see a cold water fishery, which I believe the Williams is, stay below 20 degrees Celsius, which I forget the Fahrenheit equivalent. I think that's like 65, 70. And that's what the fish, especially the trout, like to stay below that. And what we see pretty consistently is that in the summer, even those nice cool morning temperatures are getting 16, 17 degrees, and we can guess, make an educated guess that you know, by noon or by 4 p.m. in the afternoon, we're getting really close, if not exceeding that 20-degree mark. But I don't have the temperature numbers off the top of my head. But we luckily don't usually see it 20 degrees before noon when everyone is out sampling. So if I started seeing that, we would do some more investigation. But so it's really riding that line, but that's pretty typical of most of the rivers in the area.
So we're getting close towards the end of the program. I wanted to see if we could capture some last minute quick questions. Susan, I saw you quickly raise your hand there. You want to jump in?
Yeah, I don't know whether it's a quick question, but we've had
Oh,
a
that's okay.
significant runoff event above the river in Lower Bartonsville. Doesn't directly feed into the river until maybe another mile or so, but it was caused by somebody stupidly digging a giant pond on a slope, which immediately eroded the first time it rained in October after they built it. And it's brought all the sediment down into the ponds that used to be the old mill ponds that are just north of the bridge. It's been a horrendous problem. And winter has stopped it for now, but we're not looking forward to the spring melt to see what's going to happen. And supposedly there's some regulatory action being taken, but it wasn't immediate, and this happened several times. So I don't know what the result will be later on, farther downstream. It does come through from the pond through the stream that goes through our property, which then winds around through some beaver wetlands and rejoins the Williams, right around Williams Road, actually, north of Brockway Mills. So we might want to do some more downstream testing, Ryan.
Yeah.
Okay.
And I can fill folks in on that was reported to the Agency of Natural Resources, and it went to enforcement because it was a violation. They had no permits for that work. So it did go to enforcement, and there was enforcement agent out there. And unfortunately, once that kind of a scar has been opened up, it doesn't close quickly. So they have been required to take action to cover it, to get that land somewhat stabilized. And because it was so late in the season, there was obviously no roots going, no grass coming up at that time of year. So unfortunately, it is going to probably continue on at least through the beginning of spring into early summer, because it's going to take that long to get any grass and any coverage down on there. If you do see it continuing bad, you can expect to, certainly over the spring, because it was a mess.
I know, it's a disaster. I mean, our whole neighborhood we're also worried about future flooding if that were to give way in a big rain event, which we're getting bigger and bigger rain events. People's houses could be flooded. It's crazy. And unfortunately, enforcement after the fact doesn't do much at all. Yeah,
and then I'll make the point that's why we rely on the eyes and ears of you folks in the community. If you see that kind of thing happening, or you're concerned about it, the absolute best thing to do right off is to write on the homepage of the Agency of Natural Resources is a report of a suspected violation. And if you enter the information in that, we have to respond to that. You know, we can't ignore it. We are required by law to respond to those complaints. So if you see it out there, the sooner you get that to the agency, the better. And the
Yeah, it was
enforcement
reported.
officers have to go out there.
Yeah, it was reported on the first rainstorm, but what I would advise everybody else, if you hear heavy equipment and you don't know who's logging in your neighborhood, go investigate, because it could be somebody tearing up the land without a permit.
Yeah, it happens. I will say it happens all too frequently. I know of another one upstream on the Williams, where the exact same thing happened. Somebody decided to build a pond without permits, you know, and they don't think because they're out in the middle of nowhere in the woods, they don't think anybody's going to notice, except for the fact that the water doesn't stay in the woods.
Everybody's downstream. Yeah.
So it's always a really sad situation. And unfortunately, it takes far too long to heal itself.
Frank, I think you also had raised your hand.
Yeah, just a couple of quick things. Anyone who wants to continue, I'm assuming no one's evacuating or excusing themselves from being a water testing sampler. If you do, I need a note from your teacher, your mother, and a few other significant others. But thank you to all of those people. It is neat to notice, and it didn't show up on Ryan's map, that the southern branch of the Williams River, which follows along Popple Dungeon Road, if you know the area, has always turned up clean. So there is.
Yeah, that's
good
why we
news
don't
out there.
monitor it anymore.
Yeah. Ryan took that off the list because the person who did it was just like, I never get anything. I feel bad. But I think it is neat to be able to know that there are some success stories. That idea of that erosion that has been mentioned is really important, especially along the middle branch, because as you head west on Route 11, you can see significant areas where the land is giving way. And so we'll have to continue to monitor that and see how things go. But it's really, it's great to see the data. It's great to see the people that have been involved in our community leaders. Arnie is on the select board being part of this, because I think that's where we start to get that grassroots movement. So thank you for doing that. It's nice to hear what's going on.
Peter?
You're muted.
Marie mentioned once that one of the cleanest brooks in the county was on the Williams River, right? Skunk Hollow Brook that flows through Bartonsville. I think the state calls it Trib 11 or something.
Oh, yeah. Trib 11 is
Also known as Skunk Hollow Brook.
when there's no official name for a brook, we call it Trib number 3 or Trib number 5, depending on where it is. But yeah, that's one of our prime reference sites. It's got really excellent water quality and fish habitat and everything else.
I think most of the watershed's in Springfield, but the lower end comes down through Bartonsville.
And Margot pointed out that she couldn't find, on the Agency of Natural Resources homepage, it's way at the bottom.
Yeah,
There's a tan banner at the bottom, and it says, "How do I report a violation?" So it's right on that homepage. If you need to do it, please do it as soon as you think it's necessary, because the sooner we get out there, the better.
So any last minute questions or comments before we wrap up for the evening?
I saw John's quick question. John, you can reach out to me. I'm the coordinator for the Williams River site. And if you Google me, unfortunately, I will show up in a variety of places. Most of them are good places to be Googled to. But I'm part of the Chester Conservation Committee. I think I'm linked in the Telegraph article as well. And you can find me in the phone book, that old thing that we used to look at, you know. But we'd be happy to have you join us as a sampler and go from there. Way to go, John. just dial 802 first now, because it's not easy enough to just dial, 7 digits. We have to dial 10.
Well, coming from out of state, I've been doing that for the last 30, 40 years, so.
Well, it's been wonderful having everyone gather together tonight and to be able to focus on the Williams River, its watershed, its tributaries, and its waters. And if you have any further questions, we just encourage you to reach out to one of the watershed partners. And if we can't answer the question for you, we can point you in the right direction. So thank you everyone for coming, and we look forward to future monitoring on the Williams River and getting to know the river even more.
Thank you, everybody.
Thanks.
Good night.
Thanks, everyone.
Thank you.